Welcome, Hornets, and thank you for joining me. Today, we're going to be taking a look at how do we find a rectangular equation out of two parametric equations. And we're going to take something that's actually very easy to start with. Now, in most cases, the easiest is the best. Okay, so you can always make things harder for yourself, but I see no reason to do that. Okay, so please be aware. We're going to start off just saying, well, what if I let x equal t and y equals negative t squared divided by 3? Then what has to be the equation in rectangular form? I'm going to take this t that's here with x, and I'm going to replace it by direct substitution, and I have my equation. Ta-da! All right. Well, what happens if it's a little bit harder then? Well, let's see what we could do. Let's say we had something like x equals the square root of 6t, and we have y equals negative 6t over 5 plus 14 over 5 plus 2 root 6t over 5. What do we do? Well, I need to find out what t is first. So I'm going to go ahead and I'm going to square both sides. And then I'm going to divide by 6. Okay? And lo and behold, I now see that I have y equals negative 6x squared over 5 plus 14 fifths plus, and x goes directly for this to give me 2x over 5. And there we have our rectangular form. Notice our goal is to try to either find out what x is in terms of t, or hopefully if it's a simple equation where x is t, we plug that into our y equals. And we should come up with an equation that is y equals in terms of x. All right. Well, what happens if it's got trig in it? And we have x equals 3 sine t, and we have y equals 3 cosine t. Well, let's see. In a situation like this, I can see that I have x over 3 equals the sine of t, and I can see that I have y over 3 equals the cosine of t. Now, if only there was a formula that had sine in it and cosine in it that related them together in some type of theorem, some type of right triangular relationship. Doggone it. What could it be? Could it be the Pythagorean theorem? Remember from our trig a while back, we said that cosine squared of x, or in this case t, plus sine squared of t would equal 1. Which means that I'm looking at the cosine of t squared plus the sine of t squared equaling 1. And by direct substitution, I can now put in, well, that has to be x squared over 9, and this has to be y squared over 9 equaling 1. And simplifying this to make it a little bit easier and to see is x squared plus y squared is equal to 9. This is a circle centered at 0. Now, I had to think about it a little bit. I had to simplify it so that I had sine of t by itself. We might even end up having to have a t by itself with an arc sine or an arc cosine. Okay? Don't let yourself be afraid of what you see. Now, as you go through and you try these, you're going to see lots of different possibilities where they could be hyperbolas or ellipses or parabolas. Okay? Once again, parametric can go all over the place. They can go right, they can go left. They can zigzag up the page. Okay? They could go up the page, turn around, go down, circle, Do an Archimedes spiral outward or inward? Lots of possibilities. Alrighty. Thank you very much, Hornets. I hope this was interesting and helpful for you. This was how do we find rectangular form when given parametric equations. Thank you very much. Bye-bye, Hornets. Cheers.